Welcome back, everyone. We have built our local networks, configured our routing, and assigned our IP addresses. But now it's time to zoom out. Today, we are tackling CompTIA A+ Core 1 Objective 2.7 Network Types and Internet Connections. We are officially mapping the digital world, looking at the global interconnectivity that ties our individual ecosystems together via fiber optic backbones, data centers, and submarine cables. To understand how traffic flows, we categorize networks by their physical scope, measuring the physical area over which devices are managed. We organize these scales from a matter of inches all the way to thousands of miles. Think of this like zooming out on a massive map. We start at the pan, inches to feet, zoom out to the LAN, a single building, further to the MAN, a campus or city, and finally to the WAN, the entire globe. Starting closest to home, we have the Personal Area Network, or PAN. This is your immediate digital bubble. We use Bluetooth for our headsets and smartwatches, pushing speeds up to 3 to 24 Mbps. If we need to process a contactless payment or instantly pair a device, we rely on NFC, which is strictly limited to 10 to 20 centimeters. And if you need internet on the go, your PAN includes tethering and hotspots, allowing you to share a single smartphone's cellular data via USB, Wi-Fi, or Bluetooth. When we expand from a single user to an entire room or building, typically spanning 1 to 2 kilometers maximum, we hit the LAN or local area network. This is your house or this exact classroom. When we cut the physical cables and use wireless access points, it becomes a WLAN. The key characteristic of a LAN is that the local organization entirely owns and manages the routing and switching hardware. Zooming out further, we reach the MAN Metropolitan Area Network. This covers a large college campus or entire city limits. If your company owns 3 different buildings in the same downtown area, a MAN connects them all together, often utilizing dedicated, high-speed fiber optic rings leased from a local telecom provider. Before we go global, let's look at a highly specialized network, the SAN, or Storage Area Network. A SAN does not provide internet access. It provides dedicated block storage. It connects massive arrays of hard drives directly to local servers so that those servers treat the remote storage as if it were a physical hard drive plugged right into their own motherboard. Finally, the WAN Wide Area Network. This covers global multi-site connections. A WAN spans across states, countries, and oceans. The ultimate example of a WAN is the internet itself. Because a WAN crosses massive geographical boundaries, you have to lease connections from internet service providers, ISPs. Let's look at the technologies they use to connect us. The undisputed king of the WAN is fiber. Fiber optics transmit data using pulses of light rather than electrical signals. It terminates at your building using an optical network terminal, or ONT, and often utilizes passive optical network, PON architecture. Fiber provides the absolute maximum speed and reliability available today. Next is cable. This delivers internet over the exact same coaxial cables used for your television. It relies on the DOCSIS standard to separate the data channels from the TV channels. While very fast, a major drawback is that it uses shared neighborhood infrastructure, meaning if everyone on your street is streaming 4K video of their dogs like Morty, Rosie, and Simon at 8 p.m., your speeds will drop. Then we have DSL, or Digital Subscriber Line. DSL rides over traditional copper telephone lines known as POTS, plain old telephone service, and connects via a standard RJ11 jack. It's older and generally slower than fiber or cable, but because phone lines exist almost everywhere, it is highly accessible. For wireless WAN connections, we use cellular and WISP. Cellular relies on 4G and 5G radio towers and a subscriber identity module, SIM card, to provide total mobility. WISP stands for Wireless Internet Service Provider. It uses a fixed antenna mounted on the side of a building, but it absolutely requires a clear, uninterrupted line of sight to the provider's transmission tower. Our final WAN technology is satellite. Traditional satellites sit in geosynchronous orbit, GEO, which provides great geographic availability, but suffers from incredibly high latency because the signal has to travel 22,000 miles out into space and back. Modern providers are shifting to low Earth orbit, LEO constellations to drastically reduce that latency. Let's test this with a few scenario applications. Scenario 1. A remote rural office needs internet, but hills and trees block all line of sight to the nearest town. Solution: satellite. Because of the hills, a WISP will fail due to lack of line of sight. Scenario 2. A business needs highly reliable symmetrical speeds for heavy cloud backups. Solution: fiber. Scenario 3. A field technician needs internet access for their laptop while driving their F-150 between job sites. Solution: cellular or a mobile hotspot for true mobility. Take a screenshot of this CompTIA A+ review matrix. This organizes everything we've covered today. Our network types scale from PAN to WAN, including SAN for block storage. Our connection types range from light-speed fiber to shared cable, RJ11 DSL, highly mobile cellular, line-of-sight WISP, and GEO versus LEO satellite. You will be coding these precise characteristics into your XP Boost interactive modules, so keep this matrix handy. To wrap up, remember the physical rules of networking. The tech industry loves new acronyms, but the laws of physics do not change. Every network is bound by its medium. Copper degrades over distance, radio waves scatter through obstacles, and light travels the fastest. By understanding the scale of your networks and the physics of your mediums, you are fully ready to architect real-world solutions. Excellent work today, class.